Welcome back to Object-Oriented Programming using Java. This course would not be complete without talking about interfaces, and that's what we're going to talk about today. We already spoke about abstract classes. Now we're going to get into the nitty-gritty of OOP, and a lot of patterns actually use interfaces. So it's very important that you understand why you would need an interface. So if I give you an example, let's say you have a switch, right? You have the switch, right? Two plugs in here, right? So this outlet, so we can call this as an outlet. This is an interface. And you're probably asking, well, how is that an interface and how does that relate to programming? Well, it actually relates a lot to programming. Why? Because this outlet, we can call it an outlet interface, allows for any device to plug in and work, right? The only thing that the device needs to do is it needs to follow a couple of examples here. The first one is that its wire or its plug. So think about, you have different devices, right? So you'll have, let's say, a blow dryer here. And I'm not very good at drawing, but I do like drawing. You have a plug, right? Then you have, let's say, even a laptop, right? So laptop that has a plug, right? You can have a radio. So if you have a laptop, or we're talking about a radio, right? You have a radio here. I don't know how to create a radio, but let's just do that with speakers here. Right, that also has to have this type of plug, right? So what are we doing here? What we're doing here is the devices themselves have to implement this specific interface, right? Or else it's not going to work, right? So they have to follow rules when these devices need to work, as every device that's electric, right? So they have to make sure that when they build this electronic device, at the end of the day, in order for it to be powered up, you must follow the rules that are provided to you by the outlet, where you'll have a plug with three male thongs there, and this way they can plug in. Now the other rule is that, I think, I'm not an electrician, so I think there has to be some type of voltage that has to be transferred, or some maximum that you can't go past. So every device that is going to plug into an outlet has to follow those rules. You have to follow that contract. And we can take this approach and apply it to programming interfaces. Why? Because what you want to do is you want to create the outlet. You want to define that when you're building software. When you define your outlet, then anybody that wants to use your outlet can implement the interface that is for that outlet and follow the rules that you need to follow according to your interface, right? In this case, they have to follow the rules for the outlet. In our case, when we program an interface, anybody that wants to implement or use our interface has to follow the rules that you've defined in your interface class. Okay, and it's very relatable, and I hope you're seeing it. Okay, so when you write an interface, number one is an interface is considered a type. It's a type. It's not really considered an object or a class. It's really a type. And the interface itself has no concrete implementation, meaning that you list out the contract methods, and anybody that implements that interface has the burden of defining those methods in their own way. Okay, in their own way. So it's very, again, and for a beginner, it's difficult to think this way in terms of programming to the interface. But what you're really doing is you're thinking abstractly. And you'll see a lot of as you go through this course and finish this course and you move on to just writing software and going into design patterns. Okay, a lot of design patterns prefer that you use an interface because it is an abstraction, and it's better to program to the abstraction than program to the concrete implementation. And that's what I tell everybody, every beginning programmer, is that once you learn OOP, you want to focus more on programming to the interface and building out interfaces, because you get to a point where you're very abstract and this other term which we call loosely coupled. So loosely coupled. So, sorry, this should be. So what I mean by loosely coupled code, what I mean by that is that every section of your application has a single responsibility, where everything, if you take out one piece of your code, nothing is tightly bounded from your other piece. So, for example, in this example here, if I eliminate the radio, right, it doesn't really matter, right? It doesn't really matter, because this radio can implement my interface, right? But it doesn't really affect what this person's doing or this person is doing, because the interface itself has a few detailed out methods that we need to implement. Okay, which means that removing any pieces of our code will not affect our interface. Okay, so again, we want to follow the rules of programming to the abstraction and using our interface so that we follow the single responsibility principle, which you'll hear about later on as you go into design patterns. So now you're probably wondering, well, how to give me an example, right? Give me a concrete example. It is very funny. You want a concrete example of an abstraction. I'm going to give you that. I'm going to give you that. So let's take a look. All right, everyone. So here's the example that I wanted to show you. So suppose we're designing a messaging system in a big application, and we have different ways to message users. We may have the ability to text message, maybe we want to give them a call, and then also we want to send them emails. So what I've created here is an interface that is called iNotify. So usually in terms of interfaces when you're building them in Java, I like using the convention of starting an interface with the letter I. This interface is going to be a contract for any class that wants to use it, or we'll call it implement the interface. The binding rule is that they have to implement send. So I hope you know where I'm going with this. What I want to do is I want to have different types of messaging classes, and they're going to implement the iNotify interface, so that when I use the iNotify type, I can instantiate any messaging class that I want and just click and just call the send method, and it should just send away, because every messaging class is going to have a different implementation, right? So for example, with emails, you're going to have the SMTP protocol, right? So that's completely different from text messaging. So text messaging, when you send a text message, there are other things going on and you're not using SMTP. And then when you make a phone call, you're also not using SMTP. You're probably using some type of dialer where you connect via an API, and you can do some type of robotic voice implementation there with code. So you see that all of them are a variety of implementations. In that case, what I can do is, for example, on the email message notifier, I'll create a class. I'm going to implement the iNotify. When I do this, it means that I have to define and implement the method send. That's part of the contract, right? And when I implement it, I'm going to provide my concrete definition, right? So I just put a system out.println line, but in real life, what you're gonna have is you're gonna have code that is going to be part of sending an email to whatever, a user or whatever, right? And inside my class, not only will I have to define the send method, I can also put other methods in here. And it doesn't make it any different than any concrete class. I just put one method because, again, it's a simple example. But of course, there's going to be more methods that you're going to use to send out an email. Okay? So as I have my send method here, you'll see that in the main, what I do is I use the iNotify as a type and declare a variable, and then I can instantiate the email message notifier. Okay, and I can do that, and I can call the send method. So that's email message notifier. We also have the phone call notifier. So this phone call notifier class is going to actually dial and make a phone call and either do a reminder or something like that for the to the user, right? And again, I'm implementing the iNotify interface, which means that I have the send method, and then I'll have my own implementation for this class that will dial up a phone. And again, I don't want you to think that you should only have one method, because that is the method that's coming from the iNotify interface. You will have other methods that will help you in sending this phone call, right, in real life. And then lastly, I also created a text message notifier class. Again, it implements the same interface, and according to the contract, I must have a send method. And in this one, we'll do all the appropriate logic to send out a text message. So we've set everything up in terms of an abstraction, right? Where iNotify is the abstract type that we're going to use to send messages. Now, it doesn't matter which way we're going to do it. It all depends on how we choose to do it, right? So how do we do that? How do we select which one to use? So in this main, what I've done is I've declared an iNotify type, right, variable. And then for this case, I am just instantiating a text message notifier. So what this means is that now notify is an instance, the instance of notify is going to point to the text message notify. And that's okay, because this text message notifier implements iNotify. So that's perfectly fine. As long as the class that you are newing up, you're instantiating, implements your interface, then you can have that interface type be the object that it's pointing to, right? And then all I have to do now is call the send method, right? And all the details are hidden within the text message notifier. So let's run this real quick. So you see that it says sending a text message. So you can picture something like this, right? Where let's say users are set up only for text messages and just text messages, right? So let's say that if we'll just do a int subscriber message type is equal to 0. So let's assume that 1 means text message, right? So what we could do is we could say if subscriber message type is equal to 1, right? We will instantiate the text message notifier and then do a send, right? Else, if subscriber message type is equal to 2, perhaps they want to receive a phone call. So we can say the following: new phone call notifier. Okay, so if we run this, let's do a 2 here. Okay, so if we run this, calling to leave a message, right? So the phone call notifier gets instantiated. Its type is I notify, right? And again, we're calling the same method, right, which is send. So again, here you're hiding the details, but you're using an abstract type pattern where you implement multiple classes, or multiple classes are implementing one interface, and that one interface can be used to send that message. Okay, so this again, it's very simple example on an interface, but this is basically the kind of like the main idea of using interfaces, where you'll have one interface, one contract, and then that contract is implemented by multiple classes, where each class will define its own method, right? And the programmer can pick and choose which individual class you can have. Now, again, this is important to understand because it is a segue to a very popular pattern called dependency injection. Um, so, dependency injection is a software development pattern that I like. It's one of my favorites. That uses interfaces all over the application. Um, Again, a little bit too advanced for this class, but you can start looking it up once you understand the interfaces in Java. And you can do dependency injection in Java, in C Sharp, any high level language, right? Even in the front end languages such as Angular, you can do dependency injection on there as well. But that is the main idea of interfaces. Okay, so I hope that this has clarified a lot of doubts in terms of interfaces. And if you have any questions or thought this video was helpful, give me a like, subscribe, and I'll see you on the next video.